Hello students, welcome to Time Online Classes. In this session, we are going to discuss a few more models in deductions. Now we are going to focus on the quantitative only and only sum. These are the terms that are being used in the recent exams. How to deal with this? We come across these two terms in the statements, not in the conclusions. Okay, this is also called as syllogism, right? Some of this topic is also referred to as syllogism. Here, we come across these terms in the statements, not in the conclusions. So when we come across this, how to draw the basic diagram? This is what we are going to discuss. Majority of the students get confused here. So we need to carefully understand how to draw the basic diagram and the alternate diagram for these kind of statements. Directions for questions 1 to 5. Each of these questions contains 3 statements followed by 2 conclusions, numbered 1 and 2. Consider the statements to be true even if they vary with the commonly known facts, and find out which of the conclusions logically follows the given statements disregarding the commonly known facts, and choose the proper alternative from the given choices. Nothing new about this. We have been practicing this for so many occasions, and then so these directions are very standard directions, and the answer choices are only 1 follows, only 2 follows, either 1 or 2 follows, neither 1 nor 2, both 1 and 2. Okay, let us go to the questions. Only a few rules are tasks. Now these are rules. A few means it is same as some. Okay, some rules are tasks. Now what does this word only indicate? Only some rules are tasks. When we generally say some A's or B's, then how about the remaining A's? The remaining A's may be B's, may not be B's. Okay, may not be B's, may be B's and may not be B's. Yes or no? Now when we say only some A's or B's, what does this mean? The remaining A's are not B's. There is no ambiguity here. Very clear. So here only some rules are tasks implies that the remaining rules are not tasks. Implies that we cannot take when we think of an alternative diagram for the given statements, we can try in any manner, but the entire rules cannot be taken inside the task. Okay, so when we come across this only few, only some statement, have this kind of indication that will help you to in visualizing the alternative diagram. But mind you, the entire task can go inside rules. There should be some gap. So even if we draw like this, rules and tasks. So according to this statement, the remaining rules have to be kept outside tasks. So here also we are keeping the remaining rules outside the task. This is valid. But we cannot take the entire rules inside the task. That is only restriction. Okay. The restriction is this area cannot go into this area. But this entire area can go inside this. Okay. This is one. The statement which is little critical, which we have to deal with carefully. A few teams are tasked. A few is same as some. So some teams are tasked. This is how we draw the basic diagram. But here we will not have any indication because we are free to take the entire circle of teams inside the task, and we are free to take the entire circle of tasks inside the teams. So there is no restriction between them. Because the statement talks about only some, we are only showing some. The entire thing can also go inside in the alternative diagram. Only rules are games. Now look at this carefully. When we say only PhDs are professors, let us understand this statement. Only PhDs are professors. So if you find Professor A, is that professor a PhD? Yes, the professor is a PhD because only PhDs can be the professors. No one else can be professors. So if a person has become a professor, implies that that person is a PhD. You come across Professor B. So definitely we can say that Professor B is also a PhD. Professor C, PhD. Any professor, PhD. So can we say that all professors any professor is PhD? Can we say that all professors are PhDs? Yes or no? So when we come across a statement like only A's are B's, it means that all B's are A's. Only PhDs are professors implies that all professors are PhDs. So only A's are B's means all B's are A's. But there is something more to it. Only PhDs are professor means no one else can be the professor. Similarly, only A's are B's implies that all the B's are A's, but apart from A, nothing else can be B. Only A should be B. Now look at this. If we come across a statement like okay, if I come across a statement like only A's are B's and some C's are A's. So only A's are B's is same as all B's are A's. So how do we draw the basic diagram? All B's are A's. Now some C's are A's. Okay, we draw like this. But understand here, this statement says only A's are B's. Nothing else can be B. So B and C, they cannot have any common area. Only A should be B's. C cannot be B's. If you have one more statement with D, D cannot be B. Okay, so if you have D here, if you have E here, you can say that none of them can be B's. Okay, now this is an important point that you have to keep in mind. Let us go ahead with this question. Only rules are games. What does this mean? It means that all games are rules. So the entire circle of games should be here. Okay. This is the basic diagram. But mind you, only rules are games implies that tasks cannot be games, teams cannot be games. Okay. So automatically it means that nothing else can be games. Now conclusion. Some games are not tasks. So some games are not tasks. Definitely yes. Actually none of the games can be tasks. Definitely some games are tasks is true. It follows. Nothing common between task and game. It cannot be. Even in the alternate diagram we have this restriction. The moment we say only rules are games, nothing else can be games. All teams being rules is a possibility. Can we take this entire circle of teams inside rules? Can we take that teams circle like this without touching games? Yes, there should be common area between task and team that we have anyway maintained, and there should be some common area between tasks and teams. Here we have maintained that, and common area between rules and tasks also. So we can take the entire circle of teams inside the rules without violating any of the given statements. So 2 is also a valid conclusion. Both 1 and 2 follow. So choice 5 is the answer. Next one. Some data are not this. So what is the basic diagram for some not? The minimum overlap diagram. Some data are not this. It is same as no data is disk. We keep them as separate circles. But how do we indicate that? Some data are not disk imply that some we have to necessarily keep outside. And this statement is not telling us about the remaining disk. So we are keeping in the basic diagram, we try to keep the circles as much away as possible. So all we need to do is show some data are outside disk that we have shown. But how do we give this indication to visualize the alternative diagram? We cannot take this entire circle of data inside the disk. Some data are not disk means some part has to be outside. We cannot take the entire circle inside the disk. But we can take the entire circle of disk inside data. Okay, there is no restriction for moving disks into data. There is only restriction in moving data into disks. Only a few mouses are disks. Only few mouses are disks. Only few means, how about the remaining disks? How much the remaining mouses? They cannot be. Only a few mouses should be inside the disk. The remaining should not be. So we cannot take the remaining mouses here. Got it? Now understand one thing. Only some A's or B's. It means that some A's or B's. It also means that remaining A's are not B's. It gives both. Some should be inside, the remaining must be outside. If we don't have this word only, then we can't say anything about the remaining. It may be inside the other circle or may not be. Okay. All mouses are keys. So all mouses are keys implies that keys circle should be all around the mouses like this. Fine. Now, all keys can never be disk. This statement says that we cannot take all keys inside the disk. We can never, will not be able to take. Is it correct? Let us check. Let us see, can we take the entire circle of keys inside the disk? As such, there is no direct statement between key and disk. When there is no direct statement between two elements, we can move them in any manner we like. But the problem is, the mouses are inside the keys, and some part of the mouses, this part of the mouses, they cannot go inside the disk. So, if we are moving this entire circle of keys inside the disk, along with this part of mouses will also go inside it. So, we can never take the entire, all keys can never go inside disk. This is correct. Yes, it can never go. Now, the second conclusion. Some data are mouses. Is there any intersection between data and mouse? No. False. So, positive conclusion false in the basic diagram. That's it. We will not take it as answer anymore. All keys can never be disk. This is the only conclusion that follows. So, only one false. No cream is milk. We cannot let them intersect even in the alternative diagram. Only milks are cheese. Now, what is the meaning of only milks are cheese? It means that all cheese are milk. So, the entire cheese should be here. But it also nothing else. Only milk should be cheese. So, this cream cannot be cheese. Some creams are butter. So, some creams are butter. Again, it says that only milk or cheese, nothing else can be cheese. So, this butter cannot be cheese also. So, this is the basic diagram for the given statements. First one. Some creams can be. We are talking about a possibility. Some creams can be cheese. Can we have intersection between cream and cheese? No, we cannot. Because only milk is cheese. So, cream cannot be cheese. Some butter being milk is a possibility. So, can we have extend this? We are talking about a possibility, right? So, we have to check directly the alternative diagram also. Can we have extend this circle butter into milk? Yes, we can. Some part of the butter can, because there is no restriction whatsoever. So, this is possible. Okay. Only conclusion 2 false. All steel or iron. Okay. No bronze is iron. They cannot intersect. A few copper are iron. A few means same as some. Some copper are iron. This is a basic diagram. Some steel being bronze is not a possibility. So it says that some steel being bronze. So steel and bronze. It says that some part of it, some part of the steel being bronze is not possible. Is it possible or not possible? Not possible. Why? The entire steel is inside iron, and iron and bronze cannot have any intersection. So, if you have to make some steel bronze possible, either the circle bronze should go inside the iron circle, or circle steel should come out of iron circle. Both are not possible. So, some steel being bronze is not a possibility is correct. It is not possible. No copper is steel. It says that no copper can be steel. It is true in the basic diagram. But When negative is true in the basic diagram, we try to check in the alternative diagram. We try to prove the opposite of it. What is the opposite of it? Some copper is steel. Some copper is steel. So can we have an intersection between copper and steel? Yes, we can. So the opposite is possible, implies that this fails in the alternative diagram. So here only one follows. Choice 1. Next one. A few clients are programs. So this is client and this is program. A few is same as some. All programs are errors. Okay. The entire circle of program should be inside errors. All commands are errors. So all commands should also be inside errors. So this is why we write the command. This is the basic diagram. In the given statements, there is no direct statement between program and command. So in the basic diagram, we keep them separate. But there is no restriction between any of these circles. So in the alternative diagram, we can let them merge with each other. Okay, let us look at the conclusions. Some clients are not errors is a negative conclusion. All clients are errors is a positive conclusion. But if you observe carefully, this is some not and all with the same terms, client and error. So this is an opposite pair. When we have an opposite pair, till in all the questions that we have answered till now, there was no opposite pair. So we were able to straight away, we were never thought of this. Either can never be an answer if you don't have an opposite pair. But of course, remember, when opposite pair is there, don't blindly mark either or as the answer. Still, it may or may not be the answer. Are you getting my mind? If you don't find an opposite pair, you can say that either or cannot be the answer. But if you find an opposite pair, there is every possibility that either or may be an answer. But never blindly mark it as the answer. Let us check here. Here we have an opposite pair. So, any answer choice is possible. Let us look at the first one. Some clients are not errors. So, some clients are lying outside error. This is true. All clients are errors. It says that all the clients are inside errors. No, this is false. When negative conclusion is true in the basic diagram, we don't finalize it as the answer. We try to check the opposite of it in the alternative diagram. What is opposite of some not? It is all. And the term should also be in the same order. All clients are errors. So now, can we draw an alternative diagram for this? Can we take this entire circle of clients inside errors? Or I'll put it this way. Can we extend the circle of errors all around clients like this? Absolutely, because there is no restriction at all. Okay, so we can prove the opposite. So this becomes false. But here the opposite is given in the second conclusion. The moment you proved it false, this automatically became true. So now when this is false, this became true. When this is false, this automatically became true. So the answer is either 1 or 2 follows. Okay. So these are all some of the very critical questions we thought we will. This will help you in the examination. There will be so that if you have a focused discussion on this, go through this video several times. You will be thorough with all these tricky questions. Okay. Thank you for being part of this session. All the best to you.